Grab NTSCtoUSB dongle, opencv2, Python wrapper. Context. I have been playing around with Python's wrapper for opencv2. I wanted to play with a few ideas and use a wide-angle camera similar to rear-view cameras in cars. I got one from a scrapped crash car. It's got 4 wires. I took an educated guess from the wire's color coding, connected up so that I power the power and ground line from a USB Type A and feed the NTSC composite plus composite from an NTSC connector. I bought an NTSCtoUSB converter like this one. It came with drivers and some off-the-shelf STID software. The problem? I used the run-of-the-mill examples online to trial test it like this. This is the output from shell. Key observations. Screenshots. In control panel, the USB dongle is shown as OEM capture in sound, video and game controllers. So it's not seen as a simple plug-and-play webcam in imaging devices. If I open the STID software, I need to configure 2 aspects. Set as composite. Set in coding as NTSC. Then the camera feed from the analog camera is shown OK within the STID application. When I open the device video channel in FLV, device capture, the device stream is just a black screen, but if I open the STID software while FLV is streaming, I get the camera's feed to stream on FLV and a black screen is shown on the STID feed. Another important difference is that there is huge latency of approx half a second when the feed is in FLV as opposed to running in STID. When running cam_capture.py as per the sample code above at some point during runtime, I will eventually get a stop error code 0 by 0000008E. Detail. If I try to print frame.shape0 or frame.shape1, I get a type error say I cannot print type none. 6. If try other cam_index, the result is always false. TLDR. In control panel, the camera device is under sound, video and game controllers, not under imaging devices. The cam_index equals 0. The capture.isAppend equals true. The frame size is none. If STID is running with composite NTSC configured, the camera works. Obviously you can't see the image with print screen and attachment, but trust me. Smile. Is there any form of initialization of the start of communication with the dongle that could fix this, i.e. emulate STID settings, composite plus NTSC? I thought I could busparate the start of comms between STID and the dongle, but it feels like I am going above and beyond to do something I thought was a key turn solution. Any constructive insights, suggestion, corrections are most welcome. Thanks. Cheers.
Okay, so after deeper investigation, the initial suspicion was confirmed, i.e. because the NTSC dongle is not handled as an imaging device. It's seen as a video controller, so similar to an emulation of a TV tuner card. It means that although we are able to call cv2.videocapture with cam_index=0, the video channel itself is not transmitting because we are required to define a bunch of parameters. Encoding, frame size, FPS rate, etc. The problem is because the device is not supported as an imaging device, calling cv2.videocapture.setParameter value doesn't seem to change anything on the original video feed. I didn't find a solution, but I found a workaround. There seems to be quite a few options online. Search for keywords DV to webcam or camcorder as a webcam. I use DVD River, this URL. I use the trial because I am cheap. Why does it work? As much as I can tell, DVD River receives the data from the device, which is set as a video controller, similar to a capture from Windows Movie Maker or PEG, and then through fairy dust outputs the frames on cam_index=0. Assume no other cam connected, as an imaging device webcam. Summary. TLDR, use DVD River or similar. I found a workaround, but I would really like to understand it from first principles and possibly generate a similar initialization of the NTSC dongle from within Python, without any other software dependencies. But until then, hopefully this will help others who were also struggling or assuming it was a hardware issue. I will now leave you with some Beckett. Ever tried? Ever failed? No matter. Try again. Fail again. Fail better.
I faced the same issue. As a workaround, I first tried the solution proposed by user 3380927 and it worked indeed. But since I didn't want to rely on an external software, I started tweaking parameters using opencv in Python. These lines of code work like a charm. You have to insert them before reading the frame for the first time. So, the full code for basic camera reading is as follows. You can then apply image processing operations as usual. Just for reference, this was my configuration. opencv 3.1.0, Python 2.7.5, Windows 8.1, Elgato video capture device. This was also shown as sound, video and amp, game controllers.
It's a few months late, but might be useful. I was working on a Windows computer and had installed the drivers that came with the device. I tried the same code as your question with an iscap from Somagic and got the same error. Since frame is none, I decided to try an if statement around it, in case it was an initialization error. Placing into the loop. The result is 01101111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111above the loop is commented out, I get 001111111111111111111. So for my device capture device, it appears to be working for all frames beyond the 5th are captured. I'm not sure why this is, but it might be a useful workaround for now. Disclaimer. Unfortunately, my camera input is currently in a radiation field, so I can't get to it for a couple of weeks to make sure it works for sure. However, the images are currently a black frame, which is expected without proper input.
If you want to say more